Hey all, in this video we're going to be looking at some redox oxidation reduction practice problems. This goes along with topic 4.9 in your notes, so I definitely recommend looking at section 4.9 prior to this, reading through and annotating it, and also trying all these problems on your own before you watch the video of me kind of guiding you through them. Okay, question 1 is just a pretty standard. Identify the elements that are oxidized and reduced in the following reaction. And before we do this, I'm going to give you all this little helpful mnemonic device, which is Leo the lion says grr. So losing electrons means you are oxidized, and gaining electrons means you are reduced. That's going to kind of be the guiding scientific principle behind this. So now let's use that knowledge and what we know about oxidation states to label all of these things. So oxygen is always a safe place to start because its oxidation state is -2 unless it's in a peroxide, which it's not in any of these. And since lead oxide is neutral, that means lead's oxidation state must be +2 here. The same kind of thing can be said for carbon monoxide. Oxygen is pretty much always -2. That means carbon must be +2. Now we move into just elemental lead. So that means elemental lead is going to have an oxidation state of 0 because all elemental things do. And then our oxygen, again, -2, but this time there's 2 of them, and since carbon monoxide is uncharged, that means the carbon must have an oxidation state of +4. Now that we've labeled everything, we can talk about what has been oxidized and what has been reduced and how we know. So the oxidized thing will have had a number increase. So we can see carbon has gone from +2 to +4. So that's how we know it has been oxidized. And the scientific principle behind that says that it has lost electrons from left to right. The reduced element, on the other hand, will have had its oxidation state lowered. So if I look through, I see lead has gone from +2 to 0, which means it has in turn gained electrons. So that's a pretty standard redox reaction. Now let's take it a big step up and look at a complete reaction that we're asked to turn into 2 half reactions and then balance them. So we're given this whole big reaction. And when we say half reactions, that means we want a reduction reaction and we want an oxidation reaction. That's a terrible A. Anyways, we want a reduction reaction and we want an oxidation reaction. So let's start with our oxidation reaction because that one looks a little bit easier to identify here. I can see that copper has a 0 oxidation state on the left and a +2 on the right. So that means that this is my oxidation reaction once I add the 2 electrons that must also be there. Because if I remember my little adage, oxidation means you're losing electrons. So this copper on the left has lost electrons, and now they're just kind of floating around. I didn't mean to erase all that. Next, I'll do my reduction half. So I did my oxidation half, and the reason my reduction half is a little harder is because it's just going to be everything else that's left, and I have quite a bit left here. So I have these guys that are on the left side, my reactant side, and I have these guys that are on my product side. And so one of the first things that I'm going to recognize is that my equation just really isn't, well, actually first let me handle my electrons. So my electrons, if I find to figure out how many electrons everything needs, because it's not quite as obvious this time, I'm going to go through and give everything oxidation states. So oxygen, -2. Nitrogen, I'll come back to that. Hydrogen must be +1. That means this nitrogen must be +5 because each of the oxygens is -2. There's 3 of them. Hydrogen is +1. It's neutral overall, so nitrogen must be +5. Hydrogen must be +1 because it's a H+. Oxygen -2, therefore nitrogen +2. And similar thing over here, -2, and each of those is going to be +1. So that tells me a little bit more specifically about like what has been reduced. Now I can find that the actual thing that has been reduced is my nitrogen. My nitrogen has gone from +5 to +2, which means that on the left side of the equation, I'm going to have to show that reduction by having 3 other electrons over here that must have been gained moving from left to right. So now I have my 3 electrons shown, but I do still have a big problem. That big problem here is that my bottom equation is just not balanced, right? I don't have a balanced bottom reaction, and that was part of the thing that it told us to do. So how is it not balanced? Well, I have 2 oxygens on the product side, and I have 3 on the reactant side. So what I'm going to do is I'm going to throw a 2 in front of my water, so that makes there be 3 oxygens on both sides. And I am going to throw a 3 right over here. And that makes it so I have 4 hydrogens on both sides. And so this now has my balanced equation, and I am ready to move on from here. Combining half reactions into a full redox reaction is a lot more common than splitting a full redox reaction into half reactions. So the good news about that is it's also quite a bit easier to do. So this time I have iron 2 that has been oxidized to be iron 3 plus an electron, and I have chlorine that has been reduced to be 2 chlorine ions. So what I really have to do here to make sure that I have a full reaction is I have to cancel out my electrons. So ultimately what that means is I have to multiply the top by 2 so that there's 2 electrons on the top on the product side that cancel out those 2 electrons on the bottom on the reactant side. So once I multiply that top equation by 2, I just rewrite everything. 2 iron 2 plus Cl2 plus 2E minus will yield 2 Fe3 plus 2E minus plus 2 Cl minus. And then I can go ahead and erase my 2 electrons because those are the same on both sides of the equation. And now my final combined half reaction should look like this. You don't want to include those electrons in. You just want to use them as kind of a guiding force to help you know what to do when combining half reactions. So we have, combining half reactions. So we've worked with combining half reactions, reducing a full reaction into 2 half reactions, and just finding what elements have been oxidized and reduced. So hopefully this gives you some more help with just redox practice. Feel free to watch or rewatch or ask any questions about any of these processes in class. Thanks.